Let's take a look at this review. And let's see. Perimeter of a triangle is 47. Two sides are equally long. Third side is 5 centimeters in the others. Two sides are equally long. This would be x, and this would be x. They're equal. And third side is 5 centimeters longer than the others. Longer. That means x plus 5. So if this one was 10, this would be 5 more, 10 plus 5. Find the length of the three sides. Perimeter is 47, which means if I add x plus x plus x plus 5, perimeter is the distance around. That should equal to 47. So I got 3x plus 5 equals 47. Take 5 over. We got 47 minus 5, which gives us 42. And then we divide both sides by 3. And we get x is equal to 14. That means that this side is 14, this side is 14, and if this is 5 more, 14 plus 5 would give us 19. So what's it say? Length of each of the two equal sides is 14, and this would be 19. Okay. Solve the following system equations by substitution or elimination. So let me clear this off. And I think I screwed up my image. There. I made it a little bit longer for any problems. So we got 3x minus 6y is equal to 6. And 9x minus 18y is equal to 23. Now really, substitution works out best if you have one of the variables with no number in front of it. Since all of these have numbers in front of them, I'm going to use the elimination, the addition method. Now this is a negative 18, and I have to think, what do I multiply times negative 6 to become a positive 18? So we multiply that by negative 3. And we'll see why. Negative 3 times 3x is negative 9x. Negative 3 times negative 6y is a positive 18y. And negative 3 times 6 is negative 18. Oh, that's interesting. Double check myself. Negative 9x plus 18y equals negative 18. Now the goal was to eliminate the y's, and they are. 18y minus 18y drops away, but we also eliminated the x's. Negative 9x plus 9x drops away. So we got nothing left on that side, or 0. Negative 18 plus 23 gives us 5. So we get 0 is equal to 5. Now what that tells us is that there is no solution. Now this is the infinite set, but the solution is the empty set. Okay, let's take a look at this one. We got 2x plus 4y minus 4z is equal to negative 2, and y plus 5z is equal to negative 29, and 3x minus 3y is equal to 3. Well, what we want to do is we want to do some grouping so we can eliminate some z's. For example, I might group the first two terms, or first two equations together. So I got 2x plus 4y minus 4z is equal to negative 2, and y plus 5z is equal to negative 29. Now our first step is to eliminate the z's. Well, this last equation doesn't even have a z. So actually it's done. I don't need to do any work there. Though I will do something I'll talk about. Now here, to eliminate the z's, I'm going to multiply the first equation by 5 and the second equation by 4, because I want these z's to have the same number in front of them. Okay, so that's going to give us 10x plus 20y minus 20z is equal to negative 10, and 4y plus 20z is equal to negative 116. Now let me double check everything here. Okay, 10x plus 20y minus 20z is equal to negative 10. 4y plus 20z is equal to 63800. Okay, that looks right. Now, again, our goal is to eliminate the z's. So we're going to have 10x plus 24y equals negative 126. Now, notice that these are all divisible by at least 2. So that'd give us 5x plus 12y equals negative 63. Now, just as a general rule, on these, if you can divide all of them by the same number, you do so. So here I'll divide everything by 3. So we got x minus y is equal to 1. Although we'll see that this probably wasn't too bad of a form to begin with. But anyway, now we have two equations with no z's and just x's and y's. So I'm going to group these together. So I got 5x plus 12y is equal to negative 63, and x minus y is equal to 1. Now our goal here is to eliminate the y's. Well, I see if I multiply the second equation by 12, then this will be 12y, this will be negative 12y. So we're going to have 5x plus 12y is equal to negative 63. 12 times x is 12x, 12 times negative y is negative 12y, 12 times 1 is 12. I'm going to add those. I get 17x, that drops away. I really should have my calculator out here. I make mistakes on these basic math errors. Let's see, 63 minus 12, negative 51. And now we're going to, excuse me, solve for x. So divide both sides by 17. And that gives us negative 3. Now we want to work our way backwards. So we're going to go to some kind of equation that just has x's and y's in it. Doesn't matter which one. This one looks easy. So we got x minus y is equal to 1. We just said x is negative 3, so put negative 3 in for the x. Now we want to solve for y. So take negative y to the right side and take the 1 to the left side. And we got y is equal to negative 4. Now we know x's and y's. We want to go to some kind of equation that has z in it. And second one probably looks the easiest. Y plus 5z is equal to negative 29. Y plus 5z is equal to negative. Y plus 5z is equal to negative 29. We just had y is negative 4, so put negative 4 in for y. Plus 5z is equal to negative 29. Take negative 4 over. It becomes a positive 4. And that gives us negative 25. And then divide both sides by 5. And you get z is equal to negative 5. So our answer would be negative 3, comma, negative 4, comma, negative 5, maybe. I always like to do a check on these because I'm not very good at these. I make a basic math error real easy. I'm going to mentally do a checkup here. If I put negative 3 in for x, my last equation, negative 4 in for y. That's negative 9 plus 12. That's 3. That checks. If I put y in here, negative 4, and negative 5 in for the z. Negative 5 times 5 is negative 25, and negative 4 does give me negative 29. And then if I put in my first equation, 2 times negative 3 is negative 6. Negative 16 is negative 22. Plus 20, that gives me negative 2. So that checks. Let's see, there's one solution. The solution is negative 3, negative 4, negative 5. Let's take a look at this one. Now this says solve it using matrices. You could, if you wanted, just use equations. Like we just did here. But I'll show it with matrices. If we're going to use equations, you do the same process. You'd first work eliminating the z's. So you have two equations with just x and y. And then you work eliminate the y's. And then you solve for x, and then you start plugging in backwards. Gosh, it's so easy to eliminate the z's on this one. I'm gonna use same process we just did. X plus y plus z is equal to 4. And I got 4x minus z is equal to 19. And 3y plus z is equal to 6. Now we have our three equations here. So we're going to group our first two equations together. So I got x plus y plus z is equal to 4. 4x minus z is equal to 19. And then I'll group my second and third one together. So I got 4x minus z is equal to 19. And 3y plus z is equal to 6. The reason why I couldn't resist doing this method is notice how the z's already cancel. X plus 4x is 5x plus y, that's gone. 4 plus 19 is 23. Over here, if I add together the equations, I got 4x plus 3y. Those z's are gone. 19 plus 6 is 25. So now I have 5x plus y is equal to 23, and 4x plus 3y is equal to 25. Now, if I want to eliminate the y's, I need this to be a negative 3y. So I'm going to multiply the first equation by negative 3. So that gives us negative 15x minus 3y is equal to negative 69. 4x plus 3y is equal to 25. Now if I add those, that gives me negative 11x, negative 3y plus 3y cancels, negative 69 plus 25. Let's see, 69, 25. That gives us negative 44. We then want to solve for x, so we divide both sides by negative 11. And we get x is equal to 4. Now we want to plug that back into one of our equations that has x's and y's. Doesn't matter which one. I'll pick the first one. So I got 5x plus y is equal to 23. We just said x is 4. So 5 times 4 plus y is equal to 23. That's 5 times 4 is 20 plus y is equal to 23. Take the 20 over. And we get y is equal to 3. Now we want to plug that back into one of these equations and solve for z. Doesn't matter which one. I'll pick the first one. X plus y plus z is equal to 4. X we said was 4, Y we said was 3, plus Z is equal to 4. So I got 7 plus Z is equal to 7 plus Z is equal to 4. Take the 7 over, and we get Z is equal to negative 3. Let me double check those. 7 minus 3 is 4. If I put 4 here, that's 16 minus a negative 3 becomes a plus 3. 16 plus 3 is 19. 3 times 3 is 9. Z is negative 3. 9 minus 3 is 6. So that checks. 4, 3, negative 3. So here, and 4, 3, negative 3. 4, 3, negative 3. Okay, I'm going to grab a drink here. Let me clear this off. And we got 6x minus 8.3y equals 51.79. 2x plus 6.8y equals negative 33.44. Now, if we work on eliminating the y's, let's see if I wrote it down correct. Okay, if we work on eliminating the y's, a very easy way to determine what to multiply everything by is you just multiply by the other number, making sure that the signs are different. So this first equation, I'm going to multiply by the other number that's in front of the y, which is 6.8. And this one I'll multiply by 8.3. And since one's already negative, one's already positive, I don't have to worry about that. 6.8 times 6 gives us 40.8. So it becomes 40.8x. 6.8 times 8.3. We get negative 56.44y. 51.79 times 6.8 gives us 352.172. 8.3 times 2, 16.6x. 8.3 times 6.8 gives us 56.4y, and 8.3 times negative 33.44 gives us negative 277.552. Assuming I typed everything in correctly. Now if I add those, 40.8 plus 16.6, and it gives us 57.4x. These drop away. 352.172 minus 277.552 gives us 74.62. Simplify your answer, type in integers or decimals. How many decimal places? That's nice. Maybe all decimal places? Okay. Maybe it comes out nice. I should try that first, I guess. Divide both sides by 57.4. Divided by 57.4. 1.3. It didn't come out nice, but it didn't come out horrible either. Now we want to plug that back into one of our equations. Doesn't matter which one. Plug it in the first one. 6x minus 8.3y is equal to 51.79. So I got 6 times 1.3 minus 8.3y equals 51.79. 6 times 1.3 is 7.8 minus 8.3y is equal to 51.79. Take 7.8 over. 1.79 minus 7.8. I hate decimals. 51 point. Probably wouldn't make a good accountant, I guess. My eyes get off so easy on these. And then divide both sides by negative 8.3. Divided by negative 8.3. And that gives us negative 5.3. So our answer would be 1.3 and negative 5.3. Let me just check it with the other one. 2 times 1.3 plus 6.8 times negative 5.3 gives us negative 33.44. That checks. 6 times 1.3 minus 8.3 times negative 5.3, 51.79. That checks. Okay. So we'll have 1.3 comma negative 5.3. Given the cost function and revenue function, find number of units X must be sold to break even. Okay, let me clear this off. Now your break even is when your cost is equal to your revenue. Let me think if that's correct. Cost is equal to the revenue. Yeah, because you take your revenue minus your costs equals 0. That means you have no money left over, but you're not going in the hole, and you're not making money either, so you're breaking even. So if I take that over, revenue is equal to costs. Okay, so our cost is 14x plus 36,000 equals revenue, which is 16x. If I solve for x, I take the 14x over. I get 36,000 is equal to 16x minus 14x. So 36,000 is equal to 2x, and then divide both sides by 2. And we'd get x is equal to 18,000. Now I'm going to double check that. 14 times 18,000 plus 36,000 versus 16 times 18,000. Okay, that checks. So 18,000. Just seemed like a lot of units. That's why I was double checking it. But I suppose if your unit's a nail, 18,000 nails maybe not be that much. Solve the following. Let me clear this off. Got 4x is equal to 20, and y is equal to 12 minus x. Now it says by substitution or elimination, but right away I notice my first equation doesn't have two variables, only has an x. So I could solve this for x. I could divide both sides by 4, and then you get x is equal to 5. And then we'll plug that into our other equation, substitute it in. So you got y is equal to 12 minus 5, which gives us 7. So our answer would be 5, 7. That seems ridiculously easy after some of the first ones. Makes me think I'm missing something. Okay, now graph the solution of the system of linear inequalities. First off, let's take a look at the y is greater than or equal to negative 3. Now y equals negative 3 is a horizontal line at negative 3. And the greater than or equal to, the line underneath means it's going to be a solid line. So it's going to be down here, be a line at negative 3. Now, I'm assuming they want us to graph all lines on this, but we'll see. This next one, 3x plus y is less than or equal to 7. Well, if I considered it's a line, we got 3x plus y, and put an equals where the inequality was. 3x plus y is equal to 7. If I were to plug in some points, like put 0 in for x, well, 3 times 0 plus y is equal to 7. 3 times 0 drops away, we get y is equal to 7. If I were to put 0 in for y, I don't want to do that. Put 1 in for x. I don't want to deal with decimals, so we try to pick values that give us nice results. So we got 3 times 1 plus y is equal to 7. 3 plus y is equal to 7. Take the 3 over, and we end up with y is equal to 4. So 0, 7. Now this is less than or equal to, so it's a solid line again. 0, 7. Better go up to where I should be. 0, 7 and 1, 4. 1, 4. And you see in the upper right, it tells you what your point is. 1, 4. So that'd be that line. Now, other one. This one may be tricky. Is there a way to just plot points? Huh. Okay, well, let's try it anyway. 4x plus minus 3y equals negative 9. And let's plug in x equals 3. I'm trying to envision something that gives me a nice answer. So I'm not sure how to work with decimals on my math lab. So if I put 3 in for x, I think this works out. 4 times 3 is 12. What I did is I mentally plugged in 0, 1, and 2, and then got to 3, and I think it works out. 4 times 3 is 12. Take 12 over. And we get negative 3y is equal to negative 21. Divide both sides by negative 3, and we get 7. 12 minus 21. Yeah. Now, what other value would work out? If I put a 4 in, that'd be 16. Take that over, that'd be negative 25. Or would it? 16, negative 9, and negative 25. That's not nice. 5. If I put 5 in here, that's 20. That'd be negative 29. 6. That's 24. Take that over. Negative 24 and negative 9. Oh, that'd work. Okay, so if I plug 6 in. So I got 4 times 6 minus 3y is equal to negative 9. Get 24 minus 3y is equal to negative 9. Take 24 over. And we get negative 33. Divide both sides by negative 3. And we get y is equal to 11. And that's great. That's not on our... Aha! If I can... Let me save that. What's this do? Makes it bigger. Doesn't expand this. So how in the world do you do this then? Negative 3. Let me try negative 3. 4 times negative 3 minus 3y is equal to negative 9. That's negative 12, and I take that over, it becomes a positive 12, which gives us 3, and then that gives us y is equal to negative 1. So it'd have negative 3, negative 1. Let me double check that. Negative 12 plus 3 is negative 9. Okay, so those 2 points will work. Oh, wow. 3, 7. So I'm dealing with this line. 3, 7. Here's 3, 7, right there. Negative 3, negative 1. Be right there. Now the question is, what region gets shaded? If I pick a test point from in here, 0, 0. Well, if I put 0, 0 in, 0 is not greater than equal, or 0 is greater than equal to negative 3, so that checks. 3 times 0, 0 plus 0, 0, 0 is less than or equal to 7. If I put 0 here and 0 here, 0 is greater than equal to negative 9, so that checks. Okay, just double checking everything as much as I can. And save that. Assuming I did my lines correct, my points, that would be your answer. It's not very confident there, do I? Solve this by graphing. 3x minus y is equal to 8. Let me clear this off. Sometimes it's a challenge with online homework systems to get it to what you want. So 3x minus y is equal to 8. 6x minus 2y is equal to 8. Now right away I see a problem. This I can divide all of them by 2, so that would give us 3x minus y is equal to 4. Compare this to this. These are both the same, except for the number is different. Now if they were exactly the same, then it would be the same line. But since the left side is the same, 3x minus y, and these numbers are different, that means there's no solution. And no solution means that they do not intersect. So it's either going to be B or D. Well, if we graph this, if I start with 3x minus y is equal to 8. If I take the negative y over and take the 8 over here, we get 3x minus 8 is equal to y. Now to graph this line, we go down to our y-intercept, 6, 7, which is negative 8. And our slope is whatever number's in front of our x, which is 3. If I write it in fraction form, that would be 3 over 1. That means we're going to go up 3, 2, 3, right 1. And assuming I could draw a straight line, that would be that graph there, which obviously is B. If I did the same thing on this one, not that you need to, but if I solve for y, I take the 4 over, take the negative, or take negative y over. Then our y-intercept is negative 4. Our slope is still 3, or 3 over 1 if I put it in fraction form. So that's up 3, right 1. 1, 2, 3, right 1. Boy, my right graph is horrible. But it looked like that, which would be B. Oops, what did I do? Are you sure I want to leave this question? No. Okay. Solution is the empty set. Doesn't intersect at all. Let me clear this off. Rebecca Leskow was a top scorer in women's professional for the 2006 with a total of 820 points. The number of two-field goals Rebecca made, two-point field goals, two-point field goals made was 67, less than double the number of three-point goals she made. Three-point goals. The number of free throws, each worth 1 point. Free throws. Okay, so we got free throws. Find how many free throws, 2-point goals, and 3-point goals Rebecca made during the 2006 regular season. Okay, so if we chose these as variables, if I'd said this was x, this is y, and this was z. Let's read it closer. The total of 820 points. That would tell us that x plus y plus z is equal to 820 points. I'm lying. 2-point goals are worth 2 points, so that'd be 2 times x plus. These are worth 3 points, so 3 times y plus free throws. That, remember, I just worth 1 point. Equals 820. Number of 2 field goals that Rebecca made was 67, less than double the number of 3-point goals. Number of 2-point goals. 2-point goals is x. Was 67 less than double the number of 3-point goals. I always have trouble with this, getting this on the right side. So let me think this through. It was double the number of 3-point goals. Let's say 3-point goals was 30. So y is equal to 30. Then, of course, I don't want the 3 there. Okay, so, or wait a minute, does it say that? Double the number of 3-point goals. Double the number of 3-point goals. Okay, so let's say there's 30. Made 30 3-point goals. Then 40. 2 times 40 would be 80 total. was 67 less than double the number of 3-point goals? $67 less, so minus 67, I should get 13. So it appears like I have the 67 on the wrong side. I would say it should be over here. Now let me think that through again. Number of 2-point field goals Rebecca made, this, it was 67 less than double the number. So double the number, 2 times that would give us 80. 67 less, 60. Okay, that setup should work. Number of free throws, each worth 1 point, she made was 23 less. Number of free throws, Z equals, was 23 less than number of 2 field goals. Number of 2-point. Well, I'm getting caught up in the words here. 23 less. Okay, the number of free throws she made was 23 less than number of 2-point. Find out how many free throws and all those. Okay. That looks like it. Write that a little cleaner. We got 2x plus 3y plus z equals 820. Now, if I take the 2y over on this side, I'm going to have a negative 2y plus x or x minus 2y is equal to negative 67. If I took this x over here, I'd have negative x plus z is equal to negative 23. We'll know after we solve this if it actually seems to make sense what our answer is. Now I want to eliminate the z's. Now the second equation is perfect. It doesn't have any z's. So we're going to group the first 2 equations together to eliminate the z's. So we've got 2x plus, or not the first 2 equations, the first one and third one. So 2x plus 3y plus z is equal to 820. And negative x plus z is equal to negative 23. And the second equation stands by itself because the z is already eliminated. Now I'm going to multiply one of these equations by negative 1. So I'll do the second equation. 2x plus 3y plus z is equal to 820. Negative 1 times negative x is x. Negative 1 times z is negative z. Negative 1 times negative 23 is 23. So that gives us 3x plus 3y. Z minus z drops away. And was that 843? Now everything appears to be divisible by 3. So we got x plus y is equal to 843 divided by 3, 281. Okay, so now we have these 2 equations to work with. So we're going to eliminate the y's. Although you could eliminate the x's, which is a little bit easier, but I'll eliminate the y's. So I'll multiply the first equation by 2. That'd work. So that'd give us 2x plus 2y is equal to 281 times 2, which is 562. And x minus 2y is equal to negative 67. X, or 2x plus x is 3x. That drops away. 562 minus 67, 495. Divide both sides by 3. 195 divided by 3 gives us 165. That's promising. If we came up with a decimal, we'd know we were wrong. Now I want to plug this back into one of my equations and solve for y. And it doesn't matter which one. Might as well pick this one. So I got x plus y is equal to 281. X we said is 165 plus y is equal to 281. Take the 165 over. And 281 minus 165, 116. Now we want to plug this back into one of our original equations and find z. And probably this is good as any. Z is equal to x minus 23. X we just said was 65, or 165. So 165 minus 23, 142. X is equal to 165, y is equal to, what in the world's that writing say? 116? 116. Z is equal to 142. Now let's go back and double check and see if that makes sense. Okay. Total points was 820. So if I take my two field goals, 2 times 165, plus my 3 point, 3 times 116, plus 142, gives us 820. That seems to make sense. And number of field 2-point goals that Rebecca made was 67, less than double the number of 3-point. Double the 3-point. 3-point was y. So double that. 116 times 2. 232. And was 67 less. So minus 67. 165. Yeah, that seems to be making sense. Now I got to enter it correct. 165, y is equal to 116, z is equal to 142. There we go. Now what's it saying? Free throws. Free throws was z, which we said was 142. 2-point goals was x, which we said was 165. 3-point is y, which we said was 116. Oh, that was an unpleasant problem. Let me clear that off. Sometimes to do the setup, I have to think of a number example. The number example helps me to wrap my mind around what the setup should be. So when I chose y is equal to 40 over on the right side, that was just an example so I could wrap my mind around what everything should be. Okay, that's this one. A woman bought some large frames for $18 each. Small frames. So, okay, large frames, small frames. And say large is x, small is y. Okay, she bought 20 frames total, so that means x plus y is equal to 20. There's 20 total. Now, large frames cost $18, so if I take 18 times the number of large frames, and small frames are $7, so I take $7 times the number of small frames, that should give us a grand total of 206. Now I'll solve this using elimination. So I'll multiply the first or addition. I'll multiply the first equation by negative 7. So I get negative 7x minus 7y is equal to negative 140. And I got 18x plus 7y is equal to 206. And if I add these, I get 11x, negative 7y plus 7y cancels, it's eliminated. What's that, 66? Negative 140 plus 206, 66. Divide both sides by 11. And you get x equals 6. Now total, there's 20. So we got x plus y is equal to 20. 6 plus y is equal to 20. Take 6 over. And we get y is equal to 14. So, large frames. Which was large? Large was x, which is 6. So we're going to have 6 large frames. And then 14 is y, which was our small frames. Now let me double check that. 6 times 18 plus 14 times 7. Grand total of 206, yeah. Geometry. I don't review these before I start in with working them. I think that'd take away kind of the fun of it. I know I get a bizarre sense of fun. Find the values of x, y, and z in a triangle to the right. This I have to remember some of my rules about triangles. One of them I know is that all the angles inside add up to 180, which would tell us that x plus y plus z is equal to 180. And another one is that two angles that form a straight line add up to 180, which means this y plus this 2x plus 5 should equal to 180. And this down here, z plus 2x minus 5, should equal up to 180. Z plus 2x minus 5. Now let's put this in the right form. So I got x plus y plus z is 180. And I got y plus 2x here, and I'll take the 5 over. 180 minus 5 is 175. Try that again. 2x has to go here. The x's want to line up. 2x plus y is equal to 175. In this one, I got 2x plus z, and take the negative 5 over, and it gives us 185. Okay, now we want to solve this system equations. We'll eliminate the z's first. Here's our first equation, second equation, third equation. So I'm going to group the first and third together. So I got x plus y plus z is equal to 180. 2x plus z is equal to 185. Now our second equation already has the z eliminated, so that's perfect. We don't need to touch it. We'll be working with that later. Now over here, I'm going to multiply one of these equations by negative 1, because we need to be a plus z and a negative z. So we got x plus y plus z is equal to 180. Negative 1 times 2x is negative 2x. Negative 1 times negative, or z is negative z. And that's negative 185. X minus 2x is negative x plus y. Z minus z cancels, is eliminated, and that's negative 5. Okay, so we have this equation now. So we got 2x plus y is equal to 175. Negative x plus y is equal to negative 5. I'm going to eliminate the y's, so I need to multiply one of the equations by negative 1. Negative 1 times negative x is x. Negative 1 times y is negative y. And that gives us positive 5. 2x plus x is 3x. Y minus y cancels. 175 plus 5 is 180. Divide both sides by 3 and you get x equals 60. Okay, now we need to plug that back into one of our equations and find out y. Guess the second equation is the best. 2x plus y is equal to 175. We just said x is 60. Plus y is equal to 175. It's 120. Plus y is equal to 175. Take the 120 over, and you get y is equal to 55. Now plug that back in and solve for z. Doesn't matter which one. I guess the first one is probably the easiest. X plus y plus z is equal to 180. So we got 60 plus y, which is 55, plus z is equal to 180. I think that's, let me get my calculator. 60 plus 55, 115, plus z is equal to 180. Take the 115 over. 180 minus 115 gives us 65. Okay, let's see if those all add up. 60 plus 65 plus 55 gives us 180. That checks. And y plus 2x, 55, plus 2 times x is 120, plus 5, 180. Z, which is 65, plus 2x, so 120 minus 5 gives us 180. Okay, those check. X, 60. Y is 55. And z is 65. 60, 55, 65. Solve the following system equations using matrices. And we could. Let me clear this off. But I'm going to use equations. Matrices really work out better in college algebra where you have a little bit larger systems equations. If you're using a calculator, matrices work out real well in most equations that were looked at in this review video. But not everybody has calculators, so I've been showing it by hand. So I got 3x minus 4y equals 4. And 6x minus 8y, and I see a problem right here, equals 14. So I got 3x minus 4y is equal to 4, and I notice these are all divisible by 2, which gives us 3x minus 4y is equal to 7. Notice how this side matches this side, but these don't. That means there's no solution. If I went through and solved it, I would see that. Okay, 14. This may be another bizarre one. Okay, so let me clear this off. And then we got negative 3x minus 6y plus 6z is equal to negative 12. Notice how those are all divisible by 3 or negative 3. That's what I say. It may be a bizarre one. 2x plus 4y minus 4z is equal to 8. Well, first off, if I divided everything by -3 in this first equation, so if I divided by -3, I would end up with x plus 2y minus 2z is equal to 4. This is x plus 2y minus 2z is equal to 4. And if I divide everything in the last equation by 2, I'd give us x plus 2y minus 2z is equal to 4. Notice how they're all the same. That means there's an infinite number of solutions, and that'd be B. That, when I was writing it down, that kind of what jumped out at me is how they were all divisible by the same number. Oftentimes that means it's one of the oddball cases. Okay, let's take a look at this one. This is jumping out at me. That might be an oddball case too, but I don't know. Notice how the second equation is all divisible by 2. It's like, why would they do that? X is equal to 5y plus 4. And this is 2x minus 10y is equal to 8. Now if I divide everything by 2 here, I'd have x minus 5y is equal to 4. If I took the 5y over here, I'd have x minus 5y is equal to 4. They're the same equation, aren't they? That would tell us that the solution set is empty set means there's no solution. But this means no matter what you put in for x and y is true. So this is the infinite solutions, even though they don't say infinite solutions. Let's take a look at this one. Got x minus 5 is equal to 0. And x plus y is equal to 4. Well, right away, I noticed that I could solve for x. So here I'll take -5 over. Then if I plug that into the other equation, I'm going to have 5 plus y is equal to 4. Take the 5 over, and we get y is equal to -1. So there's one solution. 5, -1. 5, -1. Here's a moment of truth. Let's submit the test. All right, I didn't miss any. And that'd be the review.